In this lesson, we are going to study acid-base salt, and salt portion we are going to study. So before going to the definition of salt, I have some request to all of my viewers that if you learn the topic and understand very well, then you will leave the message that doubts are clear and please subscribe my channel. Right? So we are going to write the definition of salt. Salts are the compounds formed by partial or total displacement of ionizable hydrogen atom of an acid by what? Metallic ion or ammonium ion, and vice versa. Means in simple word that H positive of acid will be displaced by metallic ion or ammonium ion, and vice versa, meaning that OH negative ions of base will be displaced by what? Non-metallic ion. So here we are taking an example, just one example I am taking, that NaOH plus dilute H2SO4, and another example we are taking NH4 NaOH 2NaOH plus dilute H2SO4. We are just taking these two, isn't it? Or MgOH whole twice plus one molecule of dilute HCl. These we are going to take. In the first reaction, for 1, 2 and 3. In the first reaction we have one Na positive. In the second reaction we have two Na positive. So what will happen? There will be the displacement of only one H positive ion of the acid. The one will still remaining. NaHSO4 plus water will be formed. Right? Second reaction, 2Na positive will displace both the hydrogen atoms. So it will form Na2SO4 plus H2O. Then we return the vice versa, meaning OH negative ion by non-metallic ion. So we are taking that MgOH whole twice plus HCl. The Cl negative ion, one Cl negative ion will displace only one OH negative ion to form MgOHCl plus H2O. Just look at this reaction. These all are neutralization reactions we are taking, isn't it? So if we take an example to understand more clearly, that HCl, another NH4Cl plus dilute HCl, right? So always remember that with base we always take dilute acid. So NaOH has one Na positive, OH negative, and your HCl has one H positive and Cl negative. NH4Cl has NH4 positive plus what? One Cl negative, and acid has one OH negative. Here will be OH negative, and dilute HCl will have one H positive and one Cl negative. What does it mean? I'm saying that you displace H positive by metallic ion, yeah, OH negative by non-metallic ion. The H positive by metallic ion and non-metallic ion, OH negative by non-metallic ion. So we can see that there is a mutual exchange of ions. The OH takes the position of Cl, or Na positive takes the position of H positive. So we will have NaCl here plus H2O. We will have NH4Cl here plus H2O. So these all are salts, and we have written acid base reaction, and this is a kind of neutralization reaction. Now we come to classify the salts. We have to study especially three side types of salts. One is normal salt, another is acid salt, and another will be basic salt. In one word, if we complete the definition, that no ionizable hydrogen atoms should be present in normal salts. Acid salts में at least one ionizable H positive ion, a hydrogen atom, because ionizable term we have already added, of acid must be present, right? In basic salt, OH negative ion of base must be present. So if I say that normal salts are formed by total displacement and acid salts are formed by total displacement, normal salts are formed by total displacement. Whose total displacement? Either H positive acid by metallic or ammonium ion, or OH negative of base by non-metallic ion. Acid salt is found by partial displacement method. Basic salt also formed by partial displacement method, right? So here we will have some examples. If you go for normal salt, that NaCl, no ionizable hydrogen, KCl, no ionizable hydrogen, Na2CO3, no ionizable hydrogen, K2CO3, no ionizable hydrogen, Na2SO4, no ionizable hydrogen, Na3PO4, no ionizable hydrogen, and what about CH3COONA? Has it ionizable? No. Why? Because CH bond is non-ionizable and non-polar. So these are the normal salts. NH4Cl. So these H are of NH4, not of acid. And ammonium sulfate, NH4 whole twice, SO4, etc. These all are normal salts. When we come to acid salt, they are formed by partial displacement, and they have at least one ionizable hydrogen atom of an acid. So we have some example: NaHCO3, NaHSO4, NH4, HCO3, NH4 bracket HSO4. So this H is of acid. That is, this H, underlined H, is the acid of H2CO3. Underlined H is the acid of H2SO4, isn't it? That's why they are called acid salt, and they are formed by the partial displacement of ionizable hydrogen of an acid by metallic or ammonium ion. Basic salt, if we take MgOHCl, definitely it is a basic salt. PbOHCl, it is a basic salt. AlOH whole twice Cl, it is a basic salt, because they have the ionizable hydrogen of base. So they are formed by what? Partial displacement method, isn't it? So these are the salts which you have to study very well, and they will maybe asked in the board examination, isn't it? But for our knowledge, we will go through mixed salt, double salt, as well as what, complex salt. We will go through these salts as an example. What do we mean by mixed salt? We are taking an example, NaKCO3. We are taking an example, MgBrCl. Double salt, we are taking potash alum. We are taking an example of potash alum, and the example is K2SO4 dot Al2SO4 whole thrice dot 24 H2O, isn't it? Another complex salt we are taking, potassium ferrocyanide, K4FeCN whole 6. How will you identify that it's a mixed? See, two types of metallic ion and two different non-metallic ions. That's why it is a mixed. Potassium sulfate and aluminum sulfate. Potassium sulfate and aluminum sulfate both are what kind salt? They are the normal salts, right? They are the normal salts. But when they are mixed with water and combined with water of crystallization, so they will be converted into what? Double salt. In a complex salt, that K4FeCN whole 6. What is it? K4FeCN whole 6. So this is a complex. Why is it complex? The question is, why is it complex? 4K positive plus FeCN whole 6 4 negative. Complex ion means group of metal and non-metal. That's why it is called complex, right? That's why it is called which kind? It is complex, isn't it? Now we will come to the method of preparation. Methods of preparation. So method of preparation starts from, if you want to prepare any compound, the first method of preparation comes is a direct combination. What kind? Direct combination or synthesis. What does it mean? That A plus B gives AB. This is a direct combination. That is irreversible combination of two or more reactants to form single product, and the reaction is not get reversed, right? The reaction is not get reversed. The first reaction we are taking, and we are taking the one of the most important reaction, red hot Fe plus dry chlorine to form, not tell, to form what? FeCl2 or FeCl3. What you are thinking, FeCl2 will not be formed, it will form FeCl3. Reason, chlorine is a strong oxidizing agent. So it will oxidize Fe into Fe3 positive, not into Fe2 positive. Isn't it? So it will form 2 Fe, 3 Cl2 and 2 FeCl3. So here the question is asked, number of questions are asked. How is it prepared in the laboratory? We pass chlorine gas first of all through concentrated sulfuric acid to remove moisture. Isn't it? We pass chlorine gas through concentrated, so here is a moist chlorine which is passed through concentrated sulfuric acid, because chlorine is an acidic gas, and concentrated H2SO4 is hygroscopic. This chlorine is acidic gas, sulfuric acid is also acidic, but hygroscopic. What does it mean? It will absorb what? Moisture from chlorine, so that there should be no HCl present there. Isn't it? So what will happen? Here we will get dry chlorine, and then this dry chlorine is passed through red hot iron fillings. These are red hot Fe fillings, right? And when chlorine gas is passed through red hot Fe, that vapors of FeCl3 are formed. Isn't it? What will be formed? Vapors of FeCl3 will be formed, which will be collected in the conical flask as a brown scale. Yellowish brown scale it is actually. The brown form में they will be collected. But here this FeCl3 needs to get dried. Reason? Because it is a deliquescent substance. FeCl3 is kept dried by using a desiccating agent which is called fused or anhydrous what? CaCl2, calcium chloride. Deliquescent means which absorb moisture and form solution, and desiccating means which absorb moisture and does not change the state, like hygroscopic. So this is fused or anhydrous CaCl2, which will absorb moisture from the surroundings of FeCl3 to keep FeCl3 dry. Isn't it? Otherwise, if CaCl2 is not used, then it will become moist and will form solution. Then our purpose will be failed. So in the laboratory, concentrated, that chlorine gas is first passed through concentrated sulfuric acid, which is hygroscopic nature, that is moisture absorbing, which absorb moisture from the acidic gas chlorine to give rise to dry chlorine. This dry chlorine is then passed through red hot Fe, which react with chlorine to form brown, that vapors of that FeCl3 which will be collected in the form of brown scales. But these are deliquescent substance. That FeCl3 is deliquescent, that is it absorbs moisture and just forms solution. So to keep it dry, we will have to use anhydrous or fused CaCl2 so that it may desiccate this FeCl3 formed, isn't it? Now this was the direct combination method or synthesis. Now second is very important. The point is that FeCl3 cannot be prepared by heating hydrated ferric chloride. Hydrated ferric chloride. And formula of hydrated ferric chloride is FeCl3.6H2O. So what will happen? Because it gets decomposed to form Fe2O3. So this will get decomposed. It will form Fe2O3. And what is left here? Chlorine, so HCl, and water will also be formed. How many chlorine? They are 3. So we may multiply 3, but we will not multiply 3 here because we have to go for this one, that Fe2O3, 3 oxygen present, the 2 Fe2O3. Now how many Fe become 4? We will multiply here 4, then your chlorine become 4 3 is 12. So we need to multiply 12 here. Now 6 to the 12 4 is 6 to the 12 4 is 48. So we may multiply here like 3 to the 6, 48 oxygen. You remove 6, so it is what? That if we do not multiply here Fe2O3, so here 2, we just leave it. 2 3 the 6, here 6, here will be 9 water molecules form. So 2 FeCl3.6H2O give rise to Fe2O3 Fe2O3 plus 6HCl plus 9 water molecule. So that's why FeCl3 hydrated ferric chloride cannot give ferric chloride on heating. It will get decomposed to form Fe2O3. Now we are coming to the next step is your displacement reaction. Displacement reaction. Before going to the displacement reaction, we must remember reactivity series where more reactive element displaces less reactive element from its compound. Cu, Hg, Ag, Au and Pt. This is the decreasing order of reactivity series. So this one is hydrogen. Above hydrogen are more reactive, below hydrogen less reactive than hydrogen. So simply we are taking the reaction Zn plus dilute HCl. What will be formed? Yeah, Zn plus dilute H2SO4. Another Fe plus dilute HCl. Another Fe plus dilute H2SO4. What will happen? Zn is more reactive than hydrogen and Fe is also more reactive than hydrogen because Zn and Fe both are above hydrogen in the reactivity series, right? So we have ZnCl2 plus H2, ZnSO4 plus H2, FeCl2 plus H2, FeSO4 plus H2, right? So this is a displacement method where we are preparing the salts, and these all salts are water soluble, right? So you might have understood that more reactive element displaces less reactive. You may note here that Pb is more reactive than hydrogen. So if I ask you that will Pb react with dilute hydrochloric acid or will not react with dilute hydrochloric acid, or what will happen if Pb is taken? So let me have a reaction Pb plus dilute HCl and Pb plus dilute H2SO4. What will happen here? Pb on reaction with dilute HCl to form PbCl2 plus H2. Pb on reaction with dilute H2SO4 to form PbSO4 plus H2. Reason, because Pb is above hydrogen and it is more reactive than hydrogen. So definitely the displacement reaction will occur. But problem is that will the reaction continue? Will the reaction continue? So your answer will be the reaction will get stopped. Why? The reason, because Pb will that PbCl2 and PbSO4, they are insoluble in water. The Pb insoluble in water and formed chlorides and sulfates also insoluble in water. So what will happen? First layer of Pb will react. Next layer will not react because there will be a coating of either PbCl2 or PbSO4. Right? Either PbCl2 or PbSO4. So here, very important note to remember that this question is asked, it is impractical to prepare PbCl2 or PbSO4 by the direct reaction between Pb and dilute HCl or Pb and dilute H2SO4. So why is it? This is because very well known. Now you have come to know why I am saying that it is impractical, that we should not prepare by the direct reaction of Pb and dilute HCl and Pb and dilute H2SO4. Because reaction will get stopped. Why will it get stopped? Due to formation of what? Insoluble coating. Whose coating? If dilute hydrochloric acid is taken, then coating of PbCl2. If dilute H2SO4 is taken, then coating of PbSO4. So this is the reason we cannot prepare directly. So these reactions, whatever we have taken, these reactions get stopped. Why? Because PbCl2 will get stick over Pb and PbSO4 will get stick over Pb. Then the reaction will get stopped. Isn't it? Now, next is how to prepare. Now, board is asking the question, how will you convert Pb to PbCl2, or this is the first point and the second point is Pb to PbSO4. So how to convert? We need to dissolve Pb. How to dissolve it? This Pb will be dissolved only when it will be converted into PbNO3 whole twice. PbNO3 whole twice. This because metal nitrates are soluble in water without any that exception. So here Pb plus dilute HNO3, here Pb plus dilute HNO3. And we have learned in previous previous part of this lesson that nitric acid when reacts with metals act as a strong oxidizing agent. So this nitric acid is reacting with Pb, so it is acting as oxidizing agent. Right? Here it will act as oxidizing agent. The oxidizing agent means it will oxidize Pb into Pb2 positive, and that is in the form of PbNO3 whole twice. If it is an oxidizing agent, it will get reduced to form NO plus water. Similarly, second reaction PbNO3 whole twice plus NO plus water. Now the reaction will not get stopped. The reaction will not get stopped. Then question is asked that we have to write the balanced equation. So you just learn it. 38, 3, your 24. Isn't it? Similarly here 38, 3, 24. Now this PbNO3 whole twice is completely soluble in water. So now coating will not occur. Now you may take PbNO3 whole twice with diluted Cl or PbNO3 whole twice with aqueous NaCl to prepare PbCl2. So it will form what? PbCl2 plus 2HNO3 in case of HCl and PbCl2 or PbCl2 plus 2NaNO3 in case of NaCl. So this will be the white precipitate and no more coating will occur now because you have already converted Pb into PbNO3 whole twice. So this is a 2-mark question that write the balanced chemical equation to convert Pb into PbCl2. Similarly, if you take your that Pb to PbSO4, the first you have to convert it into nitrate. Then nitrate will be treated with either dilute H2SO4 or PbNO3 whole twice will be treated with Na2SO4 solution to give PbSO4 as a white PPT plus 2HNO3 or PbSO4 as a white PPT plus 2NaNO3 will be formed. Okay. So this was the displacement method where we have learnt two questions that how will you convert Pb into PbSO4 or PbCl2, and very important point to remember that those which are below hydrogen in the reactivity series like copper does not react with what? Dilute HCl or dilute H2SO4. This is because copper is below hydrogen in the reactivity series and is less reactive than hydrogen. That's why there will be no reaction between Cu and dilute HCl, between Cu and dilute H2SO4. The reaction will not occur. No reaction and no reaction. And most important is that it will react with concentrated H2SO4. It will react with HNO3 as well. See, if we take Cu plus dilute HNO3, this HNO3 will act as what? Oxidizing agent. Cu plus concentrated H2SO4. It will react because it is what? Oxidizing agent here. Now, oxidizing property of nitric acid will convert Cu into CuNO3 whole twice, and oxidizing property of concentrated sulfuric acid convert Cu into CuSO4. Also, if we take concentrated HN3 here, it will act as a strong oxidizing agent. It will also convert Cu into CuNO3 whole twice. This is because of strong oxidizing property of dilute and concentrated nitric acid and concentrated sulfuric acid. So dilute HNO3 will give a byproduct as a gas NO and water. Concentrated will give rise to NO2 and water. Concentrated will react with copper to form CuSO4 plus H2O plus SO2. So we will balance it. In case of dilute, 38, 3, 24, and here will be 2 H2SO4 and 2 H2O. But in case of concentrated HNO3, 1, 4, 1, 22 will be the balancing. So we have here completed the displacement method. Next time we will have convert metal oxide into metal sulfate, carbonate into metal sulfate, sulfite into metal sulfate, sulfate into metal sulfate, and some laboratory preparations as well. Till then, I'm stopping the video. So please, if you watch the video and if you understood everything, every doubts are cleared, and you prepare well, then please subscribe my channel as well. Thank you.